Hello everyone, João Pereira here. Today I have a new tutorial. It's been a long time since I've done one, so today we are going to create this effect. I don't know what to call it, but it's a really nice effect. I'll just play it one more time so you can see it better. This is not rendered yet. This is open. This is a viewport preview, OpenGL preview. So let me close it and open this. So yeah, let's get started. The first thing I did was create a circle, as you can see. Let me show the parameter view. I have some playing in the background, so it feels more cozy. I don't know if you like it, just let me know. I have 52 divisions. I could resample, but it's the same thing, and I made sure it was an open arc and a polygon, because now I'm going to copy it 14 times and I give it a small rotation so it's not exactly the same, and I scale it by 0.95. If you want bigger steps, you can decrease the scale, so 0.95 worked for me. And I did a connectivity, so I can have a class attribute for each polygon. So if I come here and I display my primitive class, as you can see I have 13. I can use the prim num, but I prefer doing this way. Then I did a for each, and the for each does a by piece, so 1, 2, 3 to 14, and the piece attribute is the class we just created here. So as you can see, if I display this by single pass, you can see I have everyone here to 14. So for each primitive I did a polyframe, and the polyframe by default is like this. So I wanted to create isn't it showing? Alright, I wanted to create some tangent normals. So like this, if I did this way, as you can see the normals are not correct, so I did n here and I didn't need the normal, so it gives me a tangent normal. And then I rotated it by the detail attribute, so I came here and I created a meta import node. It gives me this, and the meta import node, if you come to the geometry spreadsheet, it gives me a iteration, a number of iterations, and a value. So the iteration is, for example, single pass. This is iteration 0, 1, 2, 3, 4, 5 to 14. So I wanted to rotate them. As you can see, if I press play, as you can see the center ones move faster than the outer ones. I don't know if you can see it because of the compression, but here we go. So to do this, I did a transform, and if I bring this here, and all I did was bring the detail attribute. So detail, I bring the for each begin, so as you can see, and I get the iteration and 0.0, and then I multiplied it by 10 and $t, because if I didn't multiply by time they would be stopped. So as you can see, dollar, as you can see, and I added 1, So the first one wouldn't be stuck. So choose, I do this, not the first one but the last one. As you can see, the last one is stuck, so I just added one and you can see it moves. Alright, so that's it. And next thing I did, let me just stop this, I did a skin facet and I blasted some polygons. I fused it, did a poly extrude, give me thickness, did another facet, and piped that in to the pop net. It's simulating, I don't want it. So to get the velocity from the normals we just created, I needed to add a fluid source. So I added the fluid source. As you can see, by default the fluid source doesn't read the normals. So if I pop this in, as you can see nothing. So in this fluid source, on the source attribute, instead of putting V for velocity, since we don't have any velocity, I just put this on N. As you can see, it creates me a velocity volume. And I didn't use any density because I didn't need it. I just need the velocity field. So let's come to velocity volumes and let me visualize it. As you can see, if I change this here, you can see the circular pattern, the velocity. And I added some core noise, really small core noise, so to fill the volume a little bit more. So after that, I piped that into the popnet as well, second input. Let me just, I have a control here, so it's easier. Let me just decrease the particle count and come to the first frame. Let me decrease it a bit more. So let's dive inside the popnet, and you can see this is by the, if you type pop network, this is the defaults, so I just use this one. Dive in the popnet, you have the pop object. I didn't change anything, I just increased the substeps on the solver to 2 and 3 and nothing else. Just make sure the to age the particles and collision that you don't need it. But so let me just disable everything so you can see the defaults. So the first input is, remember this one, the geometry we just created. So it's reading that one and scattering points on the surface. On the birth, I have my constant birth rate connected to this one, so you can change it here. Sorry, I'm a bit sick. And the seed is connecting to the wedge. I will talk about that later. I have a really low life expectancy, and I added some variance to the velocity, so looks like this. Next thing I did was create the advect by volumes. So I connect my source to the second input, and on the pop advect by volumes I use the second contest geometry, which is the second input. I update the velocity, I set the method to trace so it's more accurate, and the velocity blend is 0.5. For the velocity scale I did a scene function. So if we play this, you can see they are now rotating, they are attacking the velocity. And I did a scene function, so the scene function goes from -1 to 1, like this. So I did a fit of that from 0 to 1 to 1 to 1.2. So the velocity scales from 1 to 1.2. As you can see. 1, 1.2, 1 again. and if you multiply instead of by 5 by 40, the effect is going to be faster. So as you can see, it's much faster. Let me just keep it at 5 as well. So advanced pipe smoke, I will talk about this a little bit later. So I have a pop swirl, a pop force applying a big swirl. So if I apply this with the pops, you can see, gives me a much nicer result. Let me just play this now. Alright, and I did a wedging here as well. I will talk about that later. Then I have a pop small noise, so it's basically the same, but with a smaller amplitude and a smaller swirl size. Gives me a finer detail on the particles. And let me just cook. It's enough, as you can see. And I have a pop attract with the same expression as this one. So if you come to the pop attract, the goal is the center position. I just kept the default because the origin is here. This is a 0.0, so it's in the center. I have a pop attract to the position, and the force method, it's on accelerate, and the force scale, it's the same, so it goes from -3 to 6. And if we play this now, you can see they start to increase in size, but then they get attracted to the middle, as you can see here. And as well, you can multiply this by whatever value you want. Alright, let me just play this in real time. Get bigger, they shrink, and then I did a pop-pop. And this pop-pop, if we dive inside, it's taking in the velocity, measuring it, and comparing it. If the velocity, I have this parameter, is, let me, greater than or equal to 0.125, it's going to a two-way switch. So use input 1 if true. If this is true, then I will use the same velocity. If this is not true, I will multiply the existing velocity by 9 in the up vectors. So, sorry, and I don't need this, and I will pipe that into the velocity. So if we preview this now, if the velocity, as you can see, you get this popping on the particles, as you can see, and here, like a popping effect on the particle. It's really cool. As you can see, some particles start to go higher, sorry, not the word. As you can see, gives me a really nice effect. You can multiply this by 2 if you want them to go for the sides. And then I use a pop track. It's standard 0.25. I then delete the groups, which is, I don't need any groups for the particles, and I delete most of the attributes. So since I'm going to have this value really high, I need to delete the attributes so it doesn't occupy much space on my hard drive. So I just keep the age, the ID, the life, normal, position, and the velocity, and I reference it to out particles. If I go to my ROPNet, you can see I have a geometry node here. Excuse me. and I'm pointing to the subpath, which is out particles, and I'm writing this down. And I'm using the heap name, so it's gonna save on the same directory as my file, my save file, $os, which is running this, the version, which is referencing to a channel, and $os, and dot, $, wedge num, $f, so it's frame, and the BTU. So the wedge num, I will talk about this now. So I add this parameter here, which is the wedge, and the wedge, I basically am controlling various parameters with this. So if I go to my popnet, you can see on the first input, I think, yeah, I have a seed here. So since I wanted to have, I simulated like 1 million particles, but I did that 4 times, so 4 million particles, let's imagine. So I think it was 2 million particles, so whatever. So I just changed the seed referencing to that wedge, and I did that as well for the offset, so they weren't the same every time I cached it. I think that was it, yeah. So the wedge basically takes writes this node, but changes a parameter. So I reference it to this node, just like this here. I didn't want random samples, and I wanted to add that one parameter because this control here was controlling like 3 parameters. So I just had to change this. As you can see, they are changing. Sorry. So the name, I don't need anyone. The channel, I reference it to that null. And number of steps 4. So I just wanted to create 4 different particle simulations. The range, I reference it for -1 because 0 contains 1. So 0, 1, 2, 3, 4. 0, 1, 2, 3, sorry, that's 4 steps. So then I just rendered the wedges, and it wrote 4 times. And if I come, I think I have a read file here, yeah, read wedges. If I come here, you can see I have particles.0, wedge number 0, 1, 2, 3, and 8 gigabytes each file, so that's a lot of particles. So I then did a for each again. I did a for each. I didn't use this node because I didn't need it, but I did a for each by count and merge each iteration, and the number of iterations were the number of steps we did. So I just referenced this to here. So I have 4 iterations. And on my file, I created again another meta import node, so I can read all of these files in one single file node. So to do this, I just reference 1 version, alright, / particles. So if you come here, it's going to read particles, the version, and particles dot. So this time I use the detail attribute again, but with backticks because this is a string. So detail, I get the for each, the iteration, and .0 dot pgo dot sc. So I read all the particles. If I plug this in here, you will see I have all my particles here. Alright, so just connect this here. This is gonna calculate, so let me just put back. So I have this here so I can visualize the wedging. So if I plug this here, you can see if I scrub this, you can see I have different simulations with the same file cache. They are all different, but with just changing the seed and the offset on the turbulence gives me a different result, but they don't look too far different, which is nice. So I just turn this off, and then I needed to color these particles. So if I, this is a normal one, let me just go to a frame where there are particles. Alright, I have a attribute swap here, and inside this attribute swap, let me visualize it. You can see it gives me a nice shading on the particles. If I dive inside, it's quite simple. Let me just, I don't think I need this. I'm fitting the age. The age goes from 0 to the life. The life is the total number of seconds the particle is gonna live. So if I life age, you can see this is quite slow. So the age starts at 0 and goes to the value of the life, then dies. If I go a bit further, it's the points are changing, so you can see, but it changes. The life is always a static value, and the age goes from 0 to the life. So I fit the age between I promoted the parameter, so I fit the age between 0 and 0.85, and the source maximum is the life, of course, because they are start at 0 and go to the life. And I remap that with a spline ramp, and I plug that into a Pyro black body FOP, and I promote all parameters. So this node here gives me an XYZ value, so I need to convert this into color. So I take a color transform node, and from XYZ to RGB, and I plug that into color, and I plug that as well into a, this should be a vector, sorry, to a emit color attribute, so I can use this as an emission. So going back, and I just changed a few settings on the Pyro black body. If I change this here, you can mess with these values, the temperature. If you want it to be brighter, just increase it, play with the ramp, and get the value. Like if you don't want to use the Pyro black body, just get rid of these nodes and pipe a ramp, color ramp, and colorize it whatever way you want. Next thing I did was delete off the particles. So I at a delete swap, I deleted by range, 1 every 2. So here I have 1 million particles, here I have 500,000, sorry. I then wanted to create a Sparky look, so I had a trail swap, and preserve original trail length. I wanted 3 and trail increment 0.5. Just mess with these values, so it's gonna triple the amount of particles I had. As you can see, it gives me 3 extra particles. And then I needed to connect this, so I created a trail using a add swap, delete geometry but keep points. I removed the unused points, and I did by an attribute, so the attribute was ID. If I didn't use by ID, I would have this. So make sure by ID, and make sure you don't delete the ID attribute here, because we are going to need it here. And if I visualize this, you can see some points are not connected by lines. So I wanted to create a poly wire, and I needed to delete to generate primitives. So if I use a poly wire and I use a really small value, if I didn't delete the attributes, it would look like this. Changes. As you can see, you would get these weird points here. So to get rid of those, I use this one. Let me decrease the divisions to 3. Sorry again. Alright. So already we are having a really nice look. Then I resampled those with 5 segments. I created the width so the render could read it, and I fit it with a color. So the color red goes from 0 to 1, and I fit it between 0.01 and 0.015. So the ones on the hand, the red ones would be thinner, and I created a group so I can, because I was going to merge this, I create a group and trails. So, and that's the sparks. And the inverse, I just right click this node we used before, actions, create reference copy. So it creates me an exact copy with every parameter referenced. So if I wanted to change this form to 2, I could change this to 4, for example, and this would change here. So here I deleted the non-selected, so it's the inverse. I created the width attribute so the renderer could read it, and it's the same one as this. And I created a group and merges. And if we merge this now, it's going to take a while. Let me just go to a frame where there's not many stuff. It's going to calculate 4 times, 1 for each file we wrote. This can take up to, if I change to a frame where there's like 1 million particles, this can take like 30 seconds or so to compute. Let me just try it. As you can see, it's creating 1 for each file. It's going through the whole network. Let me turn to music. Right. Third, let's go into the last one. Alright. As you can see, it gives me a really nice look. And then I reference this as an out. And if I come to object level and display this, I have a spark render. I'm merging the out, deleting the group trails, and adding an alpha. The alpha is really simple. I'm just fitting the age as we did before, and between 1 and 0.5, and binding that to the alpha. So we get this, and I did the same for the particles. So yep, just go back. So now let's talk about the smoke. Let me just I have my poly extrude, and I wanted the normals to point inwards. Outward, sorry. Why is this? So I just add the normal and $tx, ty, tz. So they point outwards. If you want them to point inward, just put minus here. Okay. And on everyone, and it should work. I had a time shift because this was rotating and I didn't want that, so I did a time shift to stop it. I did a point swap to randomize the normals, so I bring a turbulent noise, the position I kept in the position. I multiplied the time by nothing, I don't get this, and I did a float to vector, so I can convert the time like this into a into a vector, and I can use the time as an offset. I don't need this power function, and I multiply the noise with the existing normal and I pop that into normal, so I get this random effect. And I did the same fluid source stuff. If I visualize the velocity, you can see I use the normal as a source attribute for the velocity. I added some curl noise, and this time I needed to create the density, so I did. Just turn off, as you can see, and I added some animated noise, so you have this, and I use this as a fluid source. So then I use the bound, so I can create the boundaries for my simulation. So just pump this here. This file here is reading the particle velocity. So if I display, I don't think you can see anything because this is just a velocity volume. So, but to not waste time, basically all I did was add a fluid source here, and I didn't need the density, I just needed the velocity. So I just stamped the velocity of the particles. Yeah, if I change this here, you can see it gives me a velocity, and I just cached it out using a file, using to write files, and I just wrote these files, and then I read it here. You can see anything, but the velocities are like that. And I feed that into the .NET, and I also use the previous velocity we had. I don't want to listen to this. Alright, and I pop this into the .NET. So in the .NET, I have a Pyro Solver standard. I use a smoke object and reference the bonds and the centroids. A gas fluid dynamic using the track, which is this one. And I'm merging in the three velocities as source. A source volume, input 0, which is this one, the smoke. Oh, sorry. And I'm adding the velocity, and I'm scaling it down from 0 to 1 on frame 80, 69, 79. I'm reading in from input 1 the velocity, this one, and I'm scaling it as well, keyframing it, and don't need volume, don't need temperature, just adding the velocity. And then on input 2 I have my particle velocity, and I just read it as well. And then I just have a couple of micro solvers here. You can use, you don't need to use those, you can use the these ones, they are the same but just with more control. So yeah, a gas dissipate, a gas turbulence, disturbance, gas up. I then imported the fields. I just needed the smoke and the velocity. The velocity just for the motion blur. By default, it comes with this. Just as you can see, it's really long. Just delete it, temperature, rest. Just keep those two. Alright, and then I did a volume compress, and then here I resampled the velocity. So for motion blur I didn't need the velocity to be like 1 million voxels. So if you look here, as you can see, the density is 6 million voxels, almost 7 million, and the velocity is the same for every component. For velocity x, it would be 6 million, 6 million, 6 million. So that takes a lot of disk space, and I didn't need those. I didn't need to cache that out for motion blur. So I did a volume resample. I deleted everything but the velocity, so I just have the velocity. As you can see, without the volume resample, it would be really disk costing. And here I delete the non-velocity, so I just have the density with the full voxel count, and then I merged the two and cached it out. And if you look at the file size, it's like 2 megabytes for each file, and if you didn't do this volume resample on the velocity, it would be like 100 megabytes for each file. That's a lot of disk space. I just merged it then with the particles just for visualization purposes. I then went back to here, and I read the same file from here, and I did the same particle simulation. I redid the particle simulation with another Puppet Vect5 volumes, and this time I did the third context geometry, which is the velocities from the smoke, and I popped that here with a 0.35 velocity blend. So, and then I had to recache the particles. Okay, that's all I did for the shading. If I go to my shop, I just have a mantra surface. I allowed editing of contents and enable emission. I just use point color for the diffuse 111, no reflection, no anything, just emission. And on the emission, I didn't need to multiply this, but can just use a bind and import the emit color we created on the Pyro black body and use this as a base color for the emission. And that's basically all I did for the I don't need this. For the smoke, I just used the Pyro shader, density scale of 1, and that's all I did. For the render, if I go to the RobNet, you can see I have a render smoke. I did a reference copy for these two. So I have 4 subject sparks, and I mapped the others. Here, if I come to the objects, I did the inverse. And here, again, I didn't use a matte for the smoke since I had the matte on these two. So that's all I did for this specific shot. I have a comp file, but I'm really bad at compositing, so the OpenGL preview did it for me. So thank you all guys for watching and listening. I'm João Pereira, signing out.